Hi everyone. For 8.6, we're going to stick with sequences. So we've talked about sequences twice this year, once way back in Module 4 and once yesterday in 8.5. And what we did is we wrote formulas for them depending on whether it was arithmetic or geometric using our formulas. Now, when we did that, those were what are called explicit formulas. I didn't use that term with you, I just called it a formula then. But those were actually what we call explicit formulas. And an explicit formula is one where you use the number of the term to find that term. So if I want the 7th term, plug in 7 for n. If I want to find the 100th term, I plug in 100 for n. Now, we're going to learn what's called a recursive formula today. And that's one where instead of using n, you use prior terms. So we're going to say, like, instead of saying to find the 7th term, I plug in 7 for n. I might say to find the 7th term, look at the 6th term and do this to it. Now to do that, we need a new notation. So remember, we already know that an means the nth term of a sequence. That's like our variable for sequences. If I say an, I mean any term. If I actually give you a number for n, it tells you which one. A20 means the 20th term. An is basically a variable, and it could be any term. Now, if you want to do recursive formulas, you have to start moving along the sequence. So if I said to you, an minus 1, what that means in words is the term that comes right before an. Because, for example, let's say n is 10. So then you have a10. Well, an minus 1 means 10 minus 1 is 9. It means a9. Well, a9 comes right before a10. So by using, it's called the index, whatever n is, n minus 1 is 1 less than that. It's the term that comes right before it. And once you understand that one, you can really easily adjust the index. So for example, an minus 2 is the term that comes 2 spots before an. And an plus 1 is the term that comes after an. So remember, just think of it, just throw a number in there. Sometimes it makes it easier. Let's say we're talking about a10. Then an minus 1 would be 10 minus 1 is 9, a9. That comes right before a10. And 10 minus 2 is 8, so this one would be a8. That's 2 spots before a10. And n plus 1 would be a11. That's 1 spot after a10. So by taking the n and putting a plus or minus some number on it, you're saying, I'm talking about the term that many spots before or after an. So a recursive formula, you could do something like this. If I said an equals 5 times an minus 1, what I mean in words is each term, an, is 5 times the term right before it, an minus 1. And that's basically a geometric sequence. You're saying to find any term, you take the one that came before it and you multiply by 5. If you're multiplying by 5 every time, it's geometric. Or here's another example. If I said an equals an minus 1 minus 7, then in words what I'm saying is each term, an, is the term that comes right before it, an minus 1 minus 7. That would make it an arithmetic sequence because you're subtracting 7 each time, or adding negative 7. So this is a different way of writing a formula for a sequence. Instead of just saying, okay, if I want the 7th term, I'm going to plug in 7 for n. You're saying, if I want the 7th term, I'm going to take the 6th term and do something to it. Now, in order to use a recursive formula, you need a starting point. So if you take a look at one of those that we just looked at, like an equals 5 times an minus 1, I can't make a sequence from that because I don't know what to start with. You know, what it's saying is to find any term, you take the one before it and multiply it by 5. Well, to find the first term, you don't have anything before it, so you don't know where to start. So basically what you need is a starting point. So a real recursive formula will look something like this. You have the formula, an equals 5 times an minus 1. That's the same one we were just talking about. But this thing right here is the starting point. It gives you the first term. It says a1 is 7. So the first term is 7. Now, if I want to write the first 5 terms of this sequence, it says to find any term, you take the one before it, and you multiply it times 5. So to find this term right here, I take the 7, and I multiply it by 5. That would be 35. And to find the next term, I take the 35 and I multiply it by 5. Use my calculator for this one. That's 175. And to find the next term, I take the 175 and I multiply it by 5. That would be 875. So we'll do one more. It's an 8. To find the fifth term, which is what I asked you to do, you take the 875 and you multiply it times 5. And that would be 4,375. So that's how a recursive formula works. It doesn't say to find the fifth term, you plug in 5 for n. It says to find the fifth term, you take the fourth term and you multiply it by 5. And that's what we did. This was a4 right here. To find a5, I took a4 and I multiplied it by 5. And we do that for either if I had to find a6, I would take a5 and multiply it by 5. So that's what we're doing with recursive formulas. It's just a different way of writing formulas. So let's try that question backwards. Let's write a recursive formula for this sequence right here. Now, if you're writing a formula for a sequence, the first thing you want to do is look for a pattern. And what I usually do is check for arithmetic and geometric first. And it looks to me like this is arithmetic. Looks like we're adding 4 each time. This is plus 4. This is plus 4. This is plus 4. This is plus 4. So yeah, I think this is arithmetic, and we're adding 4 each time. So if I want to write a recursive formula, I need a starting point. So I'm going to tell what a1 is. I'm going to say a1 equals -7. And then after that, I'm going to say to find any other term, an, I'm going to take the term that comes right before it, which is an minus 1, and I'm going to add 4 to it. And that's my answer. That's my recursive formula right there. So in some ways, it's a lot easier to do recursive formulas than explicit formulas. You don't have to plug numbers in and solve or anything like that. You just got to you got to understand the notation. You got to use the notation to describe in words that to find any term, you're taking the one before it and you're adding 4. Now this is a good chapter summary for us right here, this last example. We're going to take this sequence right here and we're going to write both a recursive and an explicit formula for it. Now the first thing I want you to do is recognize this is a geometric sequence because we're multiplying by 2 each time. It's times 2, times 2, times 2, times 2, times 2. So this is geometric and we're multiplying by 2. So let's do the recursive one first. For the recursive one, just like the example we just did, we need a starting point. So I'm going to do a1 equals 3. That's my first term. And then for the formula part, I'm going to say an equals, I'm going to leave a little space because I'm going to multiply, but I'm going to say it's an minus 1 times 3. I like having the 3 out front. If you put times 3 on the end, I wouldn't mark it wrong or anything, but I like having the 3 out front. And that's times 2, sorry. Oops, let's fix that. We're not multiplying by 3 each time. I got that mixed up with my a1. We're multiplying by 2 each time. That's better. Okay, so there's my recursive formula. I have my starting point. I told you what the first term was. It's 3. And then I said an equals the term before it, an minus 1 times 2. So geometric. Okay, now the second part of this question, I said, now let's find an explicit formula, which is what we did yesterday. Yesterday, we said to find a formula, we could, for geometric, once we realize it's geometric, it's AN equals A1 times R to the n minus 1. And A1 is 3, R is 2. We'll leave the n minus 1 for our formula. I don't know why my pen is working like this all of a sudden. Leave the n minus 1, that's better. And that is our explicit formula. So these are both formulas for that sequence. And this is, like I said, it's a good summary of our chapter because in blue, we have a formula using prior terms. That's what we call a recursive formula. In green, we have an explicit formula. Now, each one is good for certain things. Like if I'm just writing out the sequence, recursive is better because it's easy. It's like, yeah, I'm just going to take it, start with a 3 and then just keep multiplying by 2. And that's exactly what it is. It starts with 3 and it's times 2 times 2 times 2. But if I ask you guys what is the 100th term of this sequence, then you don't want the recursive formula because you don't want to have to write it out 100 different terms to figure it out. You want to take the green one, just plug in 100 for n, grab a calculator, it's going to tell you what the answer is. So each one has its good and bad things about it. Just make sure you know the difference. If you're asked specifically to do a recursive formula, that's the blue one. And if you're asked to do an explicit formula, that's the green one.